if y is equal to sine inverse of x into under root of 1 minus x plus root x into under root of 1 minus x square. To simplify our bracket, let's assume x is equal to sine alpha and root x is equal to sine beta. So your y will be simplified as sine inverse of this x will become your sine alpha and under root of 1 minus sine square beta plus again this root x will become sine beta and we have under root of 1 minus sine square alpha. So we can say sine alpha will be as it is, under root of 1 minus sine square beta is nothing but cos beta. In second term, your sine beta will be as it is, and under root of 1 minus sine square alpha cos alpha. So within the bracket, we will set the formula of sine alpha plus beta. And we know that sine inverse and sine are inverse function of each other. So we will get y is equal to alpha plus beta, which is nothing but sine inverse x and sine inverse root x. So we simplify our y, but we have to find out dy by dx. So just differentiate with respect to x. Differentiation of sine inverse x will be 1 upon under root of 1 minus x square plus differentiation of sine inverse root x, or we can say differentiation of sine inverse box will be 1 upon under root of 1 minus box square, or we can say root x square into differentiation of your box, which is differentiation of root x. So we have to multiply 1 upon 2 root x. So if you multiply 1 upon root within the bracket, your final answer will be 1 upon under root of 1 minus x square plus 1 upon 2 under root of x minus x square, which is given in option C. Ta-da! If y is equal to a sin x plus b cos x, then we have to find out y square plus dy by dx the whole square. So first of all, let's try to get your dy by dx. Differentiation of a sin x will be a cos x and differentiation of b cos x will be minus b sin x. Now to get y square and dy by dx square, let's square both the side. So we will get the whole square of a sin x plus b cos x, and dy by dx the whole square will be a cos x minus b sin x the whole square. So let's expand. A square sin square x plus 2 times a sin x b cos x plus b square cos square x, and similarly a square cos square x minus 2 times a cos x b sin x plus b square sin square x. So if we add equation number 1 and 2, we will get y square plus dy by dx the whole square is equal to, from first two terms, let's take a square common. So we will get sin square x plus cos square x, and this plus and minus 2 a sin x b cos x will cancel out, and from last two terms we can take b square common. So we will get cos square x plus sin square x. So finally we will get a square plus b square, which is purely constant term. So option D is your final answer. Ta-da! If fx is equal to x square minus 3x, then the point at which fx is equal to f dash x are. So to get the point, let's find out f dash x, 2x minus 3. And for required point, it is given that fx is equal to f dash x. So let's compare our equation number 1 and 2. So we will get x square minus 3x is equal to 2x minus 3. Or we can say we will get x square, this minus 3x and 2x take on the left side will give us minus 5x, and minus 3 will move on the left side will become plus 3 is equal to 0. Now to get the point, we have to simplify this. The coefficient of x square is 1, coefficient of x is minus 5, and constant term is 3. So we can say your x, which is minus b plus or minus under root of b square minus 4ac upon 2 times a can be found. So let's substitute the values. We will get 5 plus or minus under root of 25 minus 12 upon 2 times 1, which will give us x is equal to 5 plus or minus root 13 upon 2, which is not given in any option. So D is your correct answer. Ta-da! If fx is equal to mx plus c, then we have to find out f of 2. We have to find out the value of m and c. And for that, let's use the given condition. The first condition is f of 0 is equal to 1. So let's substitute x is equal to 0. So we will get f of 0 is equal to 0 plus c. Now it is given that f of 0 is 1. So we will get c is equal to 1. And the second condition is f dash 0 is equal to 1. So first of all, let's get f dash x, which is simply m into 1 plus 0. So let's substitute x is equal to 0. So here we'll get f dash 0 is equal to m, or we can say 1 is equal to m. So we get the value of m and c. So your f of x, which is mx plus c, will become 1 into x plus 1, or we can say x plus 1. So we can say your f of 2 is simply 2 plus 1 is equal to 3, which is given in option C. Ta-da! If y is equal to 3x raised to 5 plus 4x raised to 5 plus 2x plus 5, then we have to find out which differentiation will give us 0. Here you should observe that your polynomial is order of 5. That means its sixth differentiation will be 0. So option C is your final answer. Ta-da! If y is equal to x into this whole bracket plus 1 upon 2 root x, then we have to find out dy by dx. So before we go for differentiation, let's simplify. Here we have a plus b and a minus b within the multiplication. So it will be converted into a square minus b square. Or we can say here we'll get cos square x by 2 minus sin square x by 2 plus sin x plus 1 upon 2 root x. And this cos square x by 2 plus sin square x by 2 can be simplified into cos x. So we get the simplest form of y. Now we are ready to differentiate with respect to x. So we have to apply multiplication rule. Let's say your x is as it is, and we have to differentiate your bracket, which is cos x plus sin x. So its differentiation will be minus sin x plus cos x plus your bracket will be as it is, and we have to differentiate your x, which will be 1, plus differentiation of 1 by 2 root x, or we can say 1 by 2 is constant. Differentiation of 1 upon root x, which is x raised to minus 1 by 2, will be minus 1 by 2 x raised to minus 3 by 2. Now from these two terms, let's take sin x common. So we will get minus x plus 1 And from the terms of cos, let's take cos x common. So we will get x plus 1. And your last term will become minus 1 by 4. 1 upon x raised to 3 by 2, or we can say x root x. Option A is your final answer. Ta-da! In this question, we have to find out differential coefficient of a raised to x plus log x into sin x. That means we just have to find out differentiation of a raised to x plus log x into sin x. So differentiation of a raised to x will be a raised to x log a, plus, to differentiate second term, we have to apply multiplication rule. Your log x will be as it is. Differentiation of sin x will be cos x, plus sin x will be as it is. We have to differentiate log x, which will be 1 by x. So we get our final answer, which is given in option A. Ta-da! Here we have to find out differentiation of tan inverse of ax minus b upon bx plus a. To simplify this, let's say we divide numerator and denominator by a. So we will get x plus b by a and b by a into x plus 1. So here we get the formula of tan inverse of alpha plus beta upon 1 plus alpha beta, which can be simplified into tan inverse of alpha and tan inverse of beta. So here we have to differentiate tan inverse of x plus tan inverse of b by a. So we are ready to differentiate. Differentiation of tan inverse x will be 1 upon 1 plus x square, plus differentiation of tan inverse b by a will be 0, because it's a purely constant term. So your final answer is 1 upon 1 plus x square, which is not given in your option. So option D is the correct answer. Ta-da!